for it. Will it go? Sweet. I think. Oh. Let me pause that. Camera on. Hey everybody. Thanks for coming out on this Tuesday. Some of you are going to be celebrating Thanksgiving, so appreciate you coming out. I know many people are traveling and things like that if you're in the US. If you're not, just another day. Let me, I'm going to close the door here. Let me get started. So, this session, let me pull this up. So, if you haven't already, subscribe if you'd like. I do these videos every Tuesday. Your feedback is also appreciated because then it kind of guides me as to what people are interested in, what you need help with, things like that. So please send me a comment, leave me a comment, send me an email, whatever. I'm here for you guys. So what we're going to be doing today is, I'm going to pull up the slideshow here. Just going to be doing a quickie video versus compared to the other ones, just building for multiple targets. So the coolest thing about Zephyr is that you can create applications that you can use the same code base with kind of minimal configuration, minimal you don't have to really worry about the hardware in many cases, as long as it has the same kind of underlying functionality. So what I'll show you in a second is just one of the examples using the air quality wing, one of the boards that I designed a while back. It just got a refresh recently. It's used to, I'll zoom out and actually show you guys what it looks like here. So I have all this stuff hooked up, but we got the NRF9160, and then this is actually a prototype of the air quality wing, kind of new and improved. So it's got a VOC sensor, so that is on this side, the TVOC over here. It's got a header for connecting to a PM2.5, so this guy is being used as a particulate sensor. And then it also has a temperature sensor on the other side, which is used not only to monitor temperature and humidity, but that temperature and humidity data gets actually fed into the VOC sensor, as the VOC sensor is like essentially like a hot plate. So it takes into the account of the ambient temperature and humidity to kind of calculate the VOCs in the air. So what I'm going to do is I'm going to use the NRF9160 feather, and then I'm going to build for the for a particle xenon, and I can just show you just switching over. It's fairly seamless. So let's plug this back in, and I can go into it. So going back to the slideshow here. So core tenets, Zephyr, is just the multiple targets thing and making it really easy for you guys to kind of create. Maybe start with one hardware platform and move to another. It's as simple as changing the board type when you're actually doing the build. So West build -B, insert board name here, and you can do that for other ones. And then it does require some amount of configuration beforehand. So there is some differences in the configuration between, say, the Xenon and then NRF9160 Feather, and I will show them right now. So for this example code should be in the comments or in the description below. You can check it out. But for the basics example, I'm just going to use this as kind of a jump-off point. And as you can see here, there's multiple boards. So each board has a config and an overlay, which is kind of pretty standard if you're creating a project for a specific board. And in my case, what's happening in the overlay is I am setting the sensor configuration information in here in the overlay file. So this essentially allows you to reference the SGB40 in your device tree inside the code. It kind of makes it generic. And the same thing, SHTC3, that's the temperature sensor. SGB40 is the VOC sensor. And you can't really see it below in that UART2. That's where the HPMA, the PM2.5 sensor lives. So depending on what interface you're using, you might be using, let's say on one board you might be using RTC2, or you might be using UART1. So this allows you to map these parts to the interfaces that you're actually using. And that's the power of Zephyr. This is the work you need to do on the back end to make sure things are working properly. And then for the configuration file, so this is an example of the configuration file for the particle xenon. Because there's not really a good way, there is, but not really a good way to get a UART console out over USB. I've actually elected to use the Seeger RTT. So using an NRF development kit, I plug that guy into the particle xenon, and I can get the output from the device over RTT. If you find yourself using in projects using maybe a constrained communication interface, maybe the only way you can connect to your board is with some type of with a JTAG connector, then RTT happens over JTAG, and this is specific to ARM chips. You can actually get a nice console over that. Very handy for very constrained boards, because then you don't need more pins or more debug connectors or anything like that. So I'm going to switch over to VS Code. Hopefully this is still here. Excellent. And I'm just going to make it a little bit bigger. So this guy should be running. Maybe not. Hello? Let's see. It should be spitting out data. So it's spitting out, it's communicating, it's spitting out data. When I do the actual build, so demo basic, I'm just doing West build, and then this is pretty, as you guys seen from the last videos, this is kind of the command to do things. The more important part is that -P, and that is your basically your clean. That's to create a pristine build. I'm not going to do that. I guess I could just do it now just to show you what it kind of looks like, and I can make this a little bit bigger. Oh, I always forget those. One thing you can do, as I mentioned before in previous videos, is you can actually set these as CMake variables in your CMake file, so you don't have to diddle around with this every time. But it allows you to be very specific about where you place your what toolchain you're using and where you're placing that toolchain. Let's try that again. CMake variables in your and it's building, and it's building, and it's building. Dun, dun, dun. So what we'll do next, once we get that built, we can transfer it over and just show that it's still running. And then what we're going to do is I'm going to pop off or remove the NRF9160 feather and attach the particle xenon. And then I'll do a little flash action over, I have a NRF9160 dev kit, which I can use with the NRF52. So, alright, this guy is working. So I'm going to try to get out of this, see if it works. So, Newt Manager, serial image, image upload. And I've, what you didn't see is, and eventually you guys will see because I'm going to try to get a camera, but I did put it in bootloader mode, so it's in bootloader mode. So I'm loading it over that way, and then I can issue that reset command, and then it should start running. And then I'm just gonna get back into this guy. Sweet. So yeah, still running the code as expected. Now what I'm going to do is, oh, you don't even see the VS Code here. So still running. I'm gonna pop this thing off, and I'm actually going to now compile for the Xenon. So so the Xenon is complete, different ARM processor, different family. So this board, the boards are the processors are different in this case. Let's see if that will go. So while that's building, I'm gonna reassemble here. And while that's going, I'll show you. So one thing that I've done in the past is I think I have it here. I think I have it committed as well in that demo. To create an RTT session, there's a couple different ways. There are some really cool Rust tools that I've started playing with now that I've been programming a little bit in Rust. But you can check out this make file in the demo repo itself. And what you need to do is you need to first open up a debug session to kind of run that RTT session, and then you need to create a different a client which will actually connect, and that will be your console. So I'm going to first program this guy. Let's see if it works. This is one thing I did not check. It's not going here. Let's try that again. No debugger. I'll show you guys what I'm doing here, at least a little bit. So I'm connecting my mess of different development boards here, and I'm hooking it up to the Xenon, and I just need to get a different cable, wherever that is. So I have one of these NRF9160 feather testers, and I always have an extra one in here. And what I'm going to do is grab this guy. So just to give you show what's happening here. So what I have on these dev boards is there's a jumper on the on any of these Nordic dev boards. It basically forces it to use the external target, so it'll always provide power to that external target. I've also, so in order to isolate this guy's power from this guy's power, I just created a little bridge board that will that has like basically just a level shifter between the two. That way, this can operate without kind of influencing this guy, except for the JTAG, of course. Let me see if it actually wants to go now. Otherwise, I might have to switch it to a different one. So let's see if this works. Sweet, it's programming. All right, I will switch back over to VS Code, and then I will run. So we want to start with a make debug session. You can also, oh, I gotta go back. Make debug, make RTT, and both of these are just shortcuts for what you see up here in the make file. So you could always run the actual commands. They're just lengthy and annoying. So there we go. If you look here, you have you've got the JLink exe is running, and then it opens up that console, and then you get the console output, the same console output actually as expected as the NRF9160 Feather. The big difference is that it's happening over RTT, over the Seger JTAG, rather than, or the SWD pins, I mean, rather than over UART. So this is the same exact code with some minor configuration and overlay changes, and all you have to do is just change the board and change your target, and then you have it and it's running. And that's the power of Zephyr, is that you can basically take any target, any hardware target, as long as they're compatible with each other. So this one, the dependencies were I2C and UART. Most subprocessors have that. And as long as your processor is supported in Zephyr and you have those interfaces, you can kind of mesh them together. You can have a Nordic chip and an Espressif chip and Silicon Labs and whoever, and you can run the same code base on those different processors. And that's why one of the reasons why Zephyr is really powerful and really awesome, and it's been it's been fun to play with. And it's like I work on new projects where I don't have the ability to use Zephyr for whatever XYZ reason. I'm like, oh, because there are some really, really nice things about the SDK, and just makes life a little bit easier. So let's see if there's any questions. Hey Mohammed, so the question is, RTT uses the same port of the debugger, and that is correct. So let me unplug this guy, or actually I'll just I'll unplug part of this. So it's very common. The Nordic boards have the external debug connector on this corner. And sorry, I don't have a better here. I think I have another one here that actually is not. Pull these off. So Nordic dev board, they all pretty much look the same. Sometimes they extend out further if you have more functionality, more hardware. But this is the external debug connector. So this allows this processor loaded with Seger's firmware to program external targets. So in a previous life, I don't know if they had this or not. This is very early on Nordic, but I had to buy like the $800 Seger programmers because I didn't realize that all you had to do is get a dev board and then you can program as many boards as you want. Nordic does pay for a license for this, so they pay for you to have the ability to use this. So every board they make, so they pay Seger or whatever, however many dollars they produce. So this is the guy, and then if you look down here, you might be able to see it. So there's a jumper right here, and this is probably the jumper. I don't think this board is modified, so it's not bridged. But this is the jumper. It's usually in the same vicinity. It's not always in the same place. You bridge that guy, and you can always check the schematic if you download it from Nordic. You can check the schematic, and you can see, okay, which is the one hooked up, and it would be like the VTarg, and the VTarg will be jumped over to that specific pin, and the 3 volts on the board will be once you short it, it'll be shorted to that. So that's the guy. And that's the pin. If you ever want to keep this default to using external, if you ever do that and then also want to program the onboard one, you could always jump from here. So this is the output, and I believe this is the input. So you can actually take your cable here and jump it between the two once you've made that modification. So that now this is set up to program the onboard no matter what. If you do not jump that jumper, if you don't solder that jumper, there's a possibility that you will be programming the onboard chip rather than the external chip, and that's bitten me a couple times. It's like, why isn't this board updating? And sure enough, it was programming the onboard one rather than the one I was trying to program externally. So hope that helps. Let's see, any more questions? I don't think so. I think this will be a quick one for the folks in the United States. Have a great Thanksgiving, and I'll see you guys next week. If you have questions or topics you want to see me cover, shoot me a line, leave me a comment, and we'll get to it. So with that being said, oh, and there's one more thing. There is a Black Friday deal coming up for the NRF9160 Feather and the air quality wing. So for these guys, I'll put them back together. So if you are not already subscribed on my mailing list, make sure you do. It's jaredwolf.com, should be right there on the front page, and I'll send out that code on Friday, and it should be good for at least the weekend. So you guys can get both of these from here, and this guy by default is free shipping, and then this guy is I think any order after 200, something like that. But it'll be a pretty good discount for you guys, and I appreciate you. Thank you so much for coming out, and see you next week. All right, have a good